Hello learners, welcome back to education program online with me teacher Christine, taking you in mathematics for senior 3 and senior 4. So dear learners, we are still on the same part of algebra, and this part now we are on what we call the binomial expression. Sometimes we say binomial theorem. So theorem comes from the word theory. So this is the branch of mathematics that deals with the algebraic quantities. As I told you, deals with the algebraic quantities, which consists of two terms which are raised to a certain power. So remember, when we are introducing this part, we say that bi means two. We have looked at the permutation, and then we have also looked at the combination. So these two terms components form what we call the binomial expression. So we are now entering deep to the real part of what we call the binomial expression itself now. That is, we have just said it is a branch of mathematics that deals with the algebraic quantities. So we define it as we say binomial theorem. Say is the theorem or the theory that deals with algebraic quantities. That consists of two terms, algebraic quantities that consists of two terms whose sum is raised to a certain power. Two terms whose sum is raised to a certain power. Whose sum is raised to a certain power. So dear learners, that is how you define what we call the binomial theorem or theory. We are going to deal with the two terms. The two terms you find combining, because this comes from the word bi. So you will have to deal with both the term 1 and term 2. And you find that these terms are being raised to a certain power. So this is what we are going to look at. How are we going to deal with this? For example, look at this. For example, they can easily say we have A plus B. A plus B, or A plus X, or A plus X raised to 1. And then Roman Roman 2, we can have a plus x, a plus x raised to 2. So this is what they are telling us, or what we are going to deal with. So a plus b is also the same as the first term and second term, or they may say a plus x, which is raised to a certain power. So for this, the power is 1, and when we come to here, we find that the power is 2. So if we are to do what? If we are to work out or to simplify or to expand this, then we simply find that when we are to expand a plus x raised to 1, it will give us a plus x as our answer. But then when we look at Roman 2, which is a plus x raised to 2, a plus x raised to 2, it means you are going to multiply this 2 times. That is a plus x times a plus x, which will give us what? It will give us a times a, will get a square, and then a times x, we get plus a x, and then a x times a, we still get a x, and then x times a will give us x times x will give us x square. So our expression will be a square, and then plus what? Plus 2a x, and then plus x square. Dear learners, this is what we are going to look at, or that is how you simply expand this algebraic quantities, taking in mind that a stands for the first term and b stands for the x stands for the second term. As we said, the 2 terms whose sum is raised to a certain power. Then now you come and say where a is term 1, and then x is term 2. So x is term 2, and then a is term 1. So dear learners, after you have seen that you can now be able to expand any algebraic quantities, and then you arrive to a certain power, you will be able now to do what? To expand any other or any other quantities with any given power. For example, now here, our powers here are ranging from 1 up to 2, and we can easily expand, and then we come up with the final answer. What about if the power is raised to more than 3, or to the biggest? For example, maybe 9 is 5, 6, 3. How are you going to get your answer in a shortest time given? So for you to get the answer of the shortest time, then we need to look at what we call the Pascal triangle. A Pascal triangle is one of the methods that we use for expanding the quantities, algebraic quantities, but in the form of a triangle, because in primary, this knowledge is introduced to learners, especially in lower primary, where you always be given a table or a shape to fill from number 1 up to number 10. So we are going to look at what we call the Pascal triangle, and how do we use this in expanding binomial expression or binomial terms. So as I've told you that Pascal triangle, we use it especially in expanding algebraic quantities which contains a biggest power, the power which is greater than 3 or greater than 2. But before we go further, I want us to learn how do we draw the Pascal triangle. How do sketch the Pascal triangle in this case. Now I want you to look at the blackboard carefully and then see the Pascal triangle, because they will ask you expand using the Pascal triangle expression to expand the given algebraic quantities. So for you to form the Pascal triangle, then we have to look at something that will come up as a triangle. We start with our counting 1. Remember that in your primary we have this kind of lower class. They draw a pyramid which is of that kind, and then now they begin to divide it in this nature, and then they ask you fill in the missing numbers. So this pyramid is what we call a Pascal triangle, but at your level we have to know how to construct it. So you begin with 1, and then from 1 you ask yourself, when I'm counting from 1, I'll go to what? To 2. What makes me to get 2? It is when I add 1 plus 1, I will arrive to 2. So you will have 1 in this side and then 1 in this side. So when I add 1 and plus 1, I will come to get 2. Dear learners, that is how you are to do. Now from here, you will say that if I have added this 1 on the right hand side and 1 on the left hand side, then I will go and add this. I will have 1 plus 2, I will get 3. And then I will also have 3 plus 1, I will get 3. So dear learners, in the middle here we have got 3 and 3. Then now you will add 1 on the right hand, and you also add 1 on the left hand. And then now you begin to add. So you say, when I add 1 plus 3, I will get 4. And then when I add 3 plus 3, I will get 6. And then when I add 3 plus 1, I will get what? I will get 4. And then you continue on the same manner. When you finish addition, you add 1 on your right hand, add 1 on your left hand. So then now you begin 1 plus 4, I will come to 5. And then 4 plus 6, I will get 10. And then 4 plus 6 plus 4, I will get 10. And then 4 plus 1, I will get 5. So now from here you also add 1 on the right, add 1 on the left. Dear learners, this is how you construct what we call the Pascal triangle. And then now from here you will find that when I add 1 to 5, I will come up with 6. And when I add 5 to 10, I will get 15. And then when I add 10 to 10, I will get 20. And then 10 plus 5, I will get 15. And then I will add 1 on my left hand, my right hand, and then 1 on the left hand. So the pyramid will continue expanding as you continue in that nature. So you will find that when you draw this, you will find it gives you something like a triangle. It gives you what we call a triangle. So this one will give us a triangle of this kind. So we shall have a triangle of that kind. So when we join it like that, automatically it gives us the triangle. And then, dear learners, from that level, you know that this is the first line. This is line 1, the first one. We have line 2 is this one, second. And then we have the third. And then we have the fourth, and then we have the fifth, and then we have the sixth, and so on, up to where you want to reach. 6. So that is how where drafting or counting is started from. It came from people were looking at that, and that's why you find that in lower primary, especially the P1, P2, they always bring them in a pyramid form, which is in a triangle form. Then you feel it, they inject that knowledge in them. So when you come to now this upper secondary, you will now look at how do I contract it, how do I construct it. You see what is very important. So from there, you will be now asked, and you can go ahead drawing, continuing until where you want to stop. So after getting that, they will ask you using the Pascal triangle, expand the following. Expand the following. So let us look at using a Pascal triangle to expand expression. Using a Pascal triangle to expand the following. To expand expressions. To expand expressions. So we always take this one as our part 1 in how to use this, how to expand the quantities. For example, they will say expand so you say example 1, expand the following. Expand the following. Expand the following using Pascal triangle. Pascal triangle. Using the Pascal triangle, and we have A 3 plus X raised to 3, and then B we have 2 minus X. 2 minus X raised to 4. And so on and so forth. So we can start with that, and then we have C, that is 2 plus 2x. 2 plus 2 raised to 3. So dear learners, let us try to solve that examples using the Pascal triangle as the question has instructed us. So when we are expanding using a Pascal triangle, the following steps must be taken into consideration. So you put your steps to be followed. Steps to be followed. Steps to be followed. So So dear learners, this one is very important, though we don't expect them in your examination paper. But this one you have to take it into consideration seriously. That if I'm expanding using what? The Pascal triangle, what should I do first? The first step that you are supposed to do is select the line of the power given. Select the line of a given power. A given power from your Pascal triangle. And then number 2, you insert decreasing power. Insert decreasing power. I'll show you what it means by inserting a decreasing power. And then step number 3, you insert increasing power. Insert increasing power. And then lastly, you will now expand your answer. So number last, which is number 4, you expand. After you have understood these steps, then we can now go straight to our example, to our solution. We are not going to wrap this. We are going to use this in these steps. So let us look at the solution to example A. Solution. So we say part A. So our part A is 3 plus what? Plus x raised to 3. They are asking us to use the Pascal triangle. So what we do, the first step, you are to get the power. Our power is number 3. Is 3. So you come to your Pascal triangle here, check where the line 3 is. So the line 3 is in this part here, which is the third one. So you list all that elements, that is 1. We have 1 and then 3 and then 3 and then 1. So that is what you do. So after that, then we are going to insert what? The decreasing power. The decreasing power of what? Of 3. So decrease 3 from 3 power what? Power 3 to 3 power 0. And then later on you will increase x power 0 to x power 3. So that is what we are supposed to do. So let us go ahead by now expanding. So we shall have 3. We use these numbers here to multiply with the first term. So we shall have the first number here, which is 1, times what? Times term 1, which is 3, and then times term 2, which is x, and then now you say plus. You go to now the second one, which is 3. So you will have 3 times the first term, which is 3, times the second term, which is x. And then you say plus. You move to the third digit, which is 3. You also multiply 3 times the first term times the second term. And then lastly we have 1. So you say 1 times what? The first term, and then times the second term, which is x. So after you have done that expansion, you are now going to decrease. you are going to decrease the first term by decreasing the power of the first term. So we shall have 3 here. When we come here, this is our first term. So it will come to 2, and then here it will come to 1, and then here it will come to 0. And then now our second term we are going to increase. So we shall increase it starting from 0, and then we move to 1, and then we move to 2, and then we have 3. Then now from there, you can now be able to simplify. So 1 times 3 cube, we get 1 times 9 times 1. Because any number power 0 is 1. And then plus, now here we shall have 3 times 2, 3 square is 9 times x. And then we have 3 times 3 times x square. And then lastly we have 1. Any number power 0 we get 1 times x cube. That is how we expand. Then now we simplify. We say 1 times 9 times 1 we get 9 plus 3 times 9 we get 27 times x we get 27x. And then now we have 3 times 3 we get 9 times x square we get 9x square. And then 1 times 1 we get 1 times x cube, we get x cube. So dear learners, this is your final answer. So that is how you expand using the Pascal triangle. So for part B, dear learners, I'm going to show you part B, which is 2 minus x raised to what? Raised to 4. So in our solution, we say first step you select the lining of 4, the power, and our power is 4. That means we are going to select this. Yes, dear learners, we are continuing from part B. So part B, we said we select the line of the power, which is 4. So you list all the elements on the line 4, and these are the elements. After listing them like that, then now you go to expand. So here we are going to wrap this Pascal triangle. Then now we come to this part. We are going to multiply it by the power 1 times our first term, which is 2, and then times negative x, close the bracket, then plus 4 times 2 times negative x, close the bracket, plus the third one, which is 6 times the first term, which is 2 times negative x. And then the third one is 4, we say, plus 4 times 2 times negative x. And then the last one we say plus our x plus 1 times 2 times negative x. So dear learners, up to that, then now you begin to decrease the power of the first term, and now first term is 2. So you put here the power, which is 4, and then here it reduces to 3, here it reduces to 2, here it reduces to 1, and then here it reduces to 0. And then we increase the power of the first term. So here we shall have 0, and then here we have 1, here we have 2, here we have 3, and then we have 4. So from that level, we are now going to simplify. So you will say 1 times 2 raised to 4, we get 16, times any number power 0 is 1. And then we have plus 4 times 2 raised to 3 is 8, times x negative x power 1 is negative x. And then plus 6 times what? Times 4. And look here, this is negative x. So when we square it, it will give us a positive x. So this is what I wanted to show you. It will give us positive x what? Square. And then plus 4 times 2 times x raised to 3 is negative x times negative x times negative x, which will give us negative x cubed. So, and then lastly we have 1 times 1 times x raised to even number, negative x raised to even number, it will give us positive x power 4. So from here you will now simply say 1 times 16 times 1 we get 16. 4 times 8 we get 32. 32 times negative x we get negative 32x. Negative 32x. And then here we say 6 times 4 we get 20 times x square we get 24 x square. X square. And then 4 times 2 we get 8 times negative x cubed we get negative 8 x raised to 3. So dear learners, that is how we expand using the Pascal triangle. So what I wanted you to know here is that when an x is raised to any even number, the answer will come to positive. And when it is raised to any odd number, if it is a negative, it will give you, it remains a negative. So that is what I wanted you to have a difference between example 1 and part B. With this part C, with this example, learners, I want you to try part C as your exercise. With this, learners, I hope you have picked something using a Pascal triangle, how to draw it and how to expand using it. We have come to the end of our lesson, and I wish you the best for today. Goodbye.